Alright, so this is absolute value function. So remember, if you have questions, raise your hand. So just like what we did in the past two lessons, alright, these are the important points. We have 0, 0, 1, 1, 2, 2. We'll also have negative 1, 1, and negative 2, 2. Remember that this y coordinates right here, they're coming from me taking the absolute value of each x. So for example, the absolute value of negative 2, well, that's positive 2, and that's where that 2 came from, right? The absolute value of negative 1, well, that's positive 1, so that's where that came from, right? So I want you to be aware where I got these y coordinates. They came from me plugging in each one of these x values into that function to see what I got back from y, okay? So if I plot these here, this is what I have. Okay, so the absolute value function for me and also for you should be an easy one to remember because it makes the shape of a V. Alright, just like the name implies, value. Alright, so absolute value, that's the way I like to think about it. Alright, so absolute value. That's how that works. Okay, so now, what is the domain of this function? As you go up, you're spreading left and right. So that's going to be from negative infinity to positive infinity, or this is what we call all real numbers. Okay? Now, what do you think is the range? What's my lowest point?
0.
And that includes 0. Okay, so 0 is included, and my highest point is?
Infinity.
Right, positive infinity, right? So remember that in Mathland we have both positive and negative infinity. Alright, using what we learned last week, so again, if you weren't here last week, then it might be a little bit difficult to catch up at first, but hopefully you will. What happens when we have a 2, in front of our function? What does that do to the parent function? Alright, very good, MK. It stretches, so this is going to be a vertical stretch by a factor of 2, but I'm just going to write by 2. Okay, so this is going to, remember, this is going to vertically stretches. They're going to grab this function right here, and if you stretch it vertically, it's going to get thinner, right? So that's what's going to happen on this one, but we're not going to graph it or anything. All right, now, what happens here? Left, right, up, or down? Remember, x is a liar. Right 5. So this is going to be right 5. And then up 2, correct. So again, that's the one that might get you a little bit messed up. Remember, this is always the opposite. If it says minus 5, you're going to go to the right 5. If it says plus 5, like this one does, you're going to go to the left 5. But this one's always the same, okay? Now for this one, what does that negative do to it, to the function?
Reflects.
Right, reflect. All right, so if you have a negative sign in front of your function, that's going to make it reflect over the x-axis. So it's going to be basically it's almost like flipping your absolute value like this, okay? So this is going to be reflect, stretch by a factor of 2, stretch by a factor of 2. Just like we said before, this is going to be left 5 instead of right 5. So this is going to be left 5 and down 2. Does that make sense? So I kind of threw a lot of you here, but this is how that works. So what is that all that means? What I'm saying, especially for the people who are not here, when I say all of this, like reflect, stretch, left, down, what that means is that I'm going to take this original graph, this parent function, for example, for this one, right 5 and up 2, and that will be the same thing. So for example, this one, if I want to know what that one would look like, well, this function right here is going to look exactly the same, 1, 2, 3, 4, 5, and then up 2. That function will look exactly the same as my parent function, except for I have shifted this to the right 5 and up 2. That's all that means. So for the people who weren't here, that's what I mean by that. Okay? Alright, on this one, they're asking us to graph a number 11, x minus 5 plus 2, which is almost, I kind of already did that, okay, but let's do it again. Alright, so on this one right here, we're going to go to the right 5, so 1, 2, 3, 4, 5, and up 2. So this right here, now this one's not too complicated. You know it's going to look like a V, okay, it's not that big of a deal. But Leslie, what we're going to do after this is that, alright, we're going to figure out what are the useful points. Well, the useful points are the ones that I have up there, right? So normally are 0, 0, which is already right here. So I'm going to pretend like that point right there is 0, 0. Right? The other point that I have is 1, 1. So from here, if I pretend that this is my origin, then that would be 1, 1, would be right here. Right? The other point was negative 1, positive 1. So from here, if I pretend that's 0, 0, negative 1, up 1 is this. And again, from this angle, over 2, up 2, to the left 2, up 2. Right? So here's one thing that I kept saying last week, but I want to make sure you understand. Every time, it doesn't matter what graph it is. It doesn't matter what graph it is. You always want to think, okay, right one, and then what happens on the y is depending on what kind of function you have. Does that make sense? So, for example, this is, when I say right one, I mean x is 1. And when I say left one, what I really mean is that the x is negative 1. Okay, making sure. Right, moving on. What's the domain of this function? All real numbers, right? It covers everything from negative infinity to positive infinity, all right? What's my lowest point? What's my highest point? Infinity. Good. All right, moving on to 13. On number 13, you have a reflection, all right? So you have a reflection, and you have a stretch of 2. All right, so that's what's going to happen. But I'm going to start at up 1, all right? So this plus 1 means I'm going to start here on the y-axis, moving 1 up, all right? So if this right here is my absolute value function points that I need, really if you have as many as these, whoa, that's not true. If I have this right here, this is all the points that you need, really. Okay, this is the points of interest. Right, if I have a negative 2 here, right, notice that that's being stretched and reflected. Well, you can, if you don't know exactly, well, how do I graph that? What you can do here is you can multiply each one of these by negative 2. And you see what happens. All right, this right here would be negative 2, this right here would be 0, this right here would be negative 2. So these are my new y coordinates. Okay, so these are my new y coordinates. So now, normally, like I said before, I go to the right one, which I mean x is 1. So from here, if this is the origin, right 1 and down 2, because that's negative 2. And if I start from here again, if this is 0, 0, I'm going to go negative 1, negative 2. So negative 1, negative 2. So this is what this graph looks like. Domain. What's the domain? What's the domain? Yeah, say it louder. Right, this is all real numbers. Right, again, because even though it's opening down, it's covering everything. What's my lowest point? Robert, what's my lowest point, buddy?
The lowest point is
Do I have a lower point?
negative.
Right, so this is negative infinity because I don't have one, really. It just keeps going on. Those arrows means I keep going down. What is my highest point?
Study.
Yeah, it doesn't matter.
1.
Correct, and that's including 1. Okay, so that's that. Okay, let me go to the back now. So I'm going through this really fast, okay? 14, 15. Okay, so remember, if it says start with this, so we're starting with this equation right here. All right, now it says that we're going to shift up 3 and left 4. Now the left and right is going to go in here. All right, the left and right needs to go inside the absolute value, and the up 3 needs to go on the outside. Okay? Now in 15, start with f of x is equal to absolute value of x, same thing. Hibbs reflect. How do I tell you that this is reflecting if I'm writing an equation? What do I need to write here? I said Hibbs.
Oh, like,
That's what I was going to say, the negative. Since if it was a positive, it would be a negative.
Right, so this would be negative, right? And it says shift to the right 6. So minus or plus?
So it would be plus, I mean, not minus.
Minus because x is a liar, remember? And then we have down 2. So minus 2. Alright, now let me give you like 1 minute for you, all of you guys, to do 16 and 17. Alright, so try 16 and 17. Roger? Do 16 and 17. Don't look at me. Do 16 and 17. Don't look at me in the eyes. Don't do it. I'll fight. Oh, you just did it. Look by your face on.
Eyes forward.
Try it out. Try it out. Left 4, so how are you gonna write this? This is factor of 3. Where it says stretch, that should be like outside. That says shift left 4. How do you do that? So remember, x is a liar then. Good. It's the same thing. Stretch and shrink is the same thing. It's just the number is less than 1. That's what it's a string. Okay. Okay, so as always, I think you always learn better when you do it yourself, but this is y is equal to reflect. So reflect means you're going to have a negative, okay? Don't forget about that little negative. Now when it says stretch, by a factor of 3, that 3 is going to go out here. You have an x here. Now it says shift left 4. Left 4 is going to be plus 4 because I said so, okay? That's all there is to it. Alright, remember it's always going to be the opposite, don't forget. And then finally we say down 1. The down and up are going to go outside of the absolute value here. Now what's the difference between shrink and stretch?
It's, well, it's wider, and then.
Right, it is, but in terms, why did that say shrink and that says stretch if all I'm going to do after all is just write it?
It's less than.
Right, it's less than 1. So this right here, the only reason they say shrink is because this right here, 0.5 is less than 1. But it's going to be treated just like that. And then we have, well, it's not moving left or right, correct? It just says shift down. It doesn't talk about left or right. So we're just going to close it at that. Got it? Are you entertained? All right. Moving on. Last 2. All right, so 21, remember, you want to come to this point right here. Right? And then ask yourself, how far from the origin, how far left have I gone? Nathan, get your head up, buddy. How far to the left have I gone? How far up have I gone? Tell me. Nathan, you tell me since you were asleep. How far from the origin have I gone to the left? -3. Okay, so what you're trying to tell me, even though you haven't told me, is you want to put it like this, because x is a liar. Okay? And then how far up did I go from the origin? +2. Now this one's going to be the same, what you would think. Okay? Now, what else happened? Anyone? Reflect. Is upside down, so we have a minus. Is this being stretched? Remember, it's always really easy because if you start from here, normally I say over 1, down 1, or over 1, up 1. Not being stretched, right? This is going to intersect here. Why don't you do 22? I'll give you like 20 seconds. That's all you need. 20 seconds for 22. 20 seconds. All right, so try out number 22, right? So figure out. I almost lost my ring of power. Try to figure out how far to the right, how far down. Remember, x is a liar. So we'll go from there. Okay. missing one. Well, it's not negative because this is what I'm saying. It's pointing down, so it's just like that. Oh, right. Fools. Alright. Alrighty, fellas and ladies. Now let's agree on something. I did move to the right 1, 2, 3, 4. So we have x minus 4. And I moved down 3 times, right? Now the next thing, this is not being reflected, so it's not a negative. So the main thing, and I didn't look at everybody's. Maybe half of you got it, but this is being stretched because if I go to the right one, I have to go up 2 to intersect that function. Alright, so that right there tells me that this has to be a 2. Alright, that right there, that distance right here tells me the stretch, which is that right there. Alright? Alright, so remember you have a quiz tomorrow, so study up, ask questions. Alright, it's being stretched because, let me draw you one that's like over here, okay? This is a terrible example. It's not that, you see like the distance between here and here would be 1. The distance, see if I go over 1 up 1, I don't intersect that function. If I go over 1 up 2, then I intersect it. So I have to be able to touch that.